going to be talking about understanding large code bases. And so we're going to focus on three main tools that all of us are almost certainly familiar with, and hopefully all of your team is familiar with too. Xcode, LLDB, and instruments. And before I start, let me get a show of hands. How many people use Xcode daily? Okay. How many people use LLDB daily? Stopping our breakpoints. Okay. How many people use instruments daily? Yeah, a few people. So there's a couple things I'm going to try and get across here today. The first is I'm just going to go over some basics of all of these tools, but I'm also trying to give you some practical tips that you can use like when you leave today on your project. And also I'm hoping to get people to use instruments more, as there are only 2 or 3 people in the room who use it regularly, especially with some of the newer changes in the last Xcode 10 release, which gave significant new abilities to instruments. So this talk is kind of going to follow this pattern of the life cycle of a typical developer on a project. So when you start on a project, you're new and exploring a new code base. So we'll take a look at navigating in Xcode some different ways than you might be used to navigating, and using some of the smart tooling and the understanding that Xcode has of your code to navigate in a slightly different way, which might help you find things that are a little more difficult to find normally. And then we'll take a look at leveraging the debugger to see what's going on at runtime. And then we'll look at using instruments with Apple's APIs on any app to see what's happening under the hood without having to implement a whole bunch of code. And then on the second half, as we move along our life cycle, when you've been on a project for a while and you're trying to make that process easier for a new developer, how do you use some of the new features in Xcode to visualize the code? And then how do you share some LLDB commands and breakpoints that other people on your team can use, mainly specific to your app's code, and then making custom instruments and creating instrumentation and templates and things that will allow your team to see what's going on in your code without having to go through all of the code. So I found this image, and it kind of reminded me, maybe very strangely, about starting on a new project. You're kind of like this weird chicken baby. You can't really fly. You don't have feathers. Your eyes are closed. You don't know where anything is. So how do we take each of these tools in turn and see how they can open our eyes and look at the code around us? But the caveat to this first part, I'm not changing anything in the project, which, you might want to go through and change some things while you're figuring things out, but there's a lot of cases where you just want to see what's happening and not touch anything. You don't understand at all where anything is. So that's kind of the first half of this talk. So let's start out with Xcode. And some of my favorite WWDC talks have been Xcode tips, because I feel like I often, and I imagine most of you, get sort of caught in a rut using the same features and not using some of the more hidden features that they end up pointing out in those sessions. So today I'm going to look at some ways to navigate. These are some specific ways for navigating using Xcode's source code understanding, but also if you want to look for other tips, see Charlie's presentation on Monday. He goes through some more useful editor-based tips. Let's see if this works. Okay. Also, Charlie mentioned a couple open source projects. I happen to actually choose one of the ones that he mentioned, which is GitHawk, which is a GitHub client. It's all Swift. It is fairly well organized, and so it gives us a good picture of a large project. It has quite a few files, a lot of dependencies, so it gives us a way to actually look at a normal project instead of a sample. Can you guys read that text over here in the back? Or do you need me to? Okay. Is that better? Is that enough? Okay. So the first thing I want to point out is the symbol navigator. And the symbol navigator just goes through and indexes the symbols and then shows them in this, by default, hierarchical view. And then you can see all the symbols and navigate that way. But the way I tend to use this is looking through code like I normally would, starting at some point like app delegate, and you're looking through classes. And you might get to a class eventually. Like in this case, we have this GitHub client. And the GitHub client is just, kind of a general struct that contains like user information. It has a client that's an HTTP client, so it does API requests. And so one of the things that we often talk about as a team is where do you put extensions in Swift, right? Like you have extensions for protocols and all kinds of things. So we're trying to figure out, should we keep them together, put them in a bunch of different files. And you can show extensions up from this list, but I don't love navigating this way because it's hard to figure out where you were, and you have to remember which one you were on. So if you just select the symbol and go up to navigate, there is a reveal and symbol navigator, which doesn't have a shortcut by default, and it will just jump you in the symbol navigator over to the symbol in the symbol navigator, and then it shows all of your extensions just the same as the related items, but you can command click, just like any list like this, and see all the implementations. And now we can start jumping around to a particular extension and just kind of get an idea looking at the jump bar. This is in repository, issues. So these are extensions adding specific methods to deal with particular types from the GitHub API. So it allows you to at least navigate in a way that isn't your typical project tree file structure. The other thing in Xcode is looking at the call tree, the call stack, and figuring out where methods are called. And in this app, there's this badge notifications class, and it handles badging the application icon on the home screen. So this method, update badge, just does that. So if we wanted to figure out where this was called, we could search. But you can also go up to find and find call hierarchy, and you'll get a list of all the places that method is called, and then you can drill down and continue up the stack until, in this case, we reach app delegate. And I also use this, obviously when you're starting out, you may have a bug and you're trying to figure out all the call sites and look at all the data that's passed in or whatever. So this is a good place to quickly look at that. And then the other feature is some of the find filters. So this is just another find filter. And typically, you're just finding text or a regular expression. But there's also definitions and references which pare down, based on the same data that the symbols navigator uses. And so you can use that. So if we wanted to search for everywhere that implements this protocol's method, we can search for this. We could probably put func in front, but there are other examples where you might, have a symbol that you just want to see definitions for instead of, the large everything that you'll get, if you don't qualify. It also gives you the nice type icons over here. So this is a method, and then it will show protocols and extensions and things like that. Or well, not extensions in this case, but protocols and other class types in this view. So that is Xcode as a new developer. So we looked at symbol navigator, we looked at the call hierarchy, and we looked at definitions. And these are all just sort of different views. I know I don't tend to use them a lot of times when I work with other developers on our project. They don't really use these tools. And so it's just kind of a reminder that these tools exist and they're another way to kind of parse what's going on. So moving to LLDB. So LLDB provides a lot of powerful tools, and you can share your own utilities that you create. You can share breakpoints in Xcode, but you can share scripts and other LLDB code. So I want to go over some cross-application functions of this in this section. And the main ones that I picked out are breakpoint sounds, which you may have heard of before. There was some stuff going around about using breakpoint sounds in various ways. But this in particular is using breakpoint sounds and a script, so creating some kind of script that you can use in every project. And then also combining that with naming the breakpoints. And the thing about naming breakpoints, it's really more like a tag. So when you name a breakpoint, you can use the same name for many breakpoints, and then you can enable and disable them all at once. So you can create a whole suite, of breakpoints for a particular task and automatically set them to disabled until you need them, and then you can just enable them all at once. So let's take a look at that. So I've set up in my LLDB init file. The LLDB init file is in your user directory, and it's just a file that has LLDB commands in it, like you would enter in the command prompts in Xcode. So this command just tells it to import this source file, which I've put in a sounds directory. I made it a text file, but it's just a a file with more LLDB commands, just like LLDB init. So you could segregate these out into different functions. And that file just has a simple, this is kind of the main example you'll see, which is just releasing view controllers. You can also use this, another example you'll often see, it's not going to resize, is memory. So you can set a bunch of breakpoints for memory. Method calls like free and alloc, I don't find that super useful because it's incredibly noisy. But you could qualify it with conditioners as well. So if you wanted to look at exactly where it was being called. So in this case, we just set a breakpoint on a symbol name, and then we can use this platform shell to run a shell command, and we can just play a file. And this is exactly the same thing that Xcode essentially would be doing when you set a breakpoint and do the sound action. And then we can auto continue because we don't want to stop every time on these. And then we disable it by default and name it audio. So when we run our project, this will not be actually set. I guess it's set but disabled. And we don't have any breakpoints over here, so I'm not doing anything weird. Once this compiles. So I also posted the show notes, the notes for all this stuff up on the slides channel already. I just made a markdown file because my presentation doesn't have some of the code in it. And there are links to the fork I have of this repo on there as well that has some of this stuff in there. So it doesn't do anything right now if we go between view controllers, but if we pause and we run breakpoint enable audio, it'll enable the one breakpoint, and we rerun, we'll start hearing the noise, right? So every time we pop a view controller. And the idea behind this is, when you don't hear the sound, it means you have a leak of your view controller, theoretically. It can sometimes get noisy, and you can add qualifiers and stuff for classes that you don't want it to do. So that is the common breakpoints. Okay, so now on to instruments. So I think instruments is one of the most overlooked apps. I mentioned earlier that there are some new changes to Xcode 10, which was adding custom instrument ability. And again, in this section, we're trying not to change code. So instruments is a really good tool for this. It looks at logs and other data, and it can just, visualize it without actually doing anything similar to LLDB. We can just attach and not change anything. So in particular, you have to, if you know anything about the unified logging API, which was added sort of as a replacement for NSLog, it has some other characteristics, but it's simple. You just log your message to the console with some other information. And if you remember back when they introduced unified logging, I think it was Xcode 8 or 9, there was an issue where all the network logging was going into the Xcode console, and you had to set a flag to disable it. And it's kind of an indicator of how much these system APIs are logging. They log all kinds of stuff, and that's all stuff that you can see in instruments just like you could see it in the console now. And I think instruments is a better view for this. You can save trace documents easily. You have the timeline so you can see what else is going on, and you can combine multiple instruments together and see them, stacked on top of each other. So let's look at some of the logs and filtering logs and creating our own instrument to look at particular log messages. Actually, I don't want to run this. So I'm just going to run directly from instruments. So if we go and add an instrument, and we add the OS log instrument, it will just start outputting all of the console logs. And we have a lot. There's CF networking, CF bundle, and user defaults, and a bunch of other things. And the ones that jump out at me I mean, you can find anything or most things that for specific APIs that you're using in your app, but in this particular app, you'll see user notifications, so that does things like setting the badge number, right? So when you set a badge number, it will log this message. And then in this case, we have the sync defaults subsystem, which is, let me pause this. So if it's refreshing, you can just pause and it'll stop refreshing the list. So if you see here, we've got NS ubiquitous key store, key value store, errors, and other information. So this is the subsystem that is used by NS ubiquitous key value store, which is the iCloud key value store. And so you'll receive these has external changes, which is one of the delegate methods you would normally receive, but it's also in the logs, so you don't have to implement it to get, to see the same changes. And then the NS ubiquitous key store error log shows the entitlements error. So in this case, I just didn't set up entitlements for this because it's iCloud and I didn't want to do that in this project. But this gives you, a way to start seeing some of these errors that might not otherwise be shown in any other API, other than, maybe some error when you instantiate the object or something. And so we can take those. If I can find this. So we can take those and make our own instruments. This is a little risky, it's not too dissimilar from calling private API, right? Since they could change these, but it's just instruments, so you could change it any time, and it's not actually running inside of your code. So in this case, for sync defaults, I just made an instrument. An instrument's just a big XML file with a bunch of elements that correspond to some of the unified logging APIs I talked about. And we can just essentially pattern match on that ubiquitous key value store message, and then we can eventually make an instrument that outputs those. So let's just take a look at that. It's pretty simple. So when you make a custom instrument, if you've ever used extensions on Mac apps like this, it'll create a new running process that has all this stuff added in, so you don't have to install it onto your system. And we can go up here and we'll see that our instrument has been added with a debug flag. All this stuff is in the WWDC talks on this. I'm mainly showing, novel ways to use this stuff that, you may not have thought of before. So in this case, we log out the error and we just plot it on the timeline. And this other case is the has changes, which I don't have any because it doesn't connect. But so you can imagine you could see a bunch of these as changes were happening, and that's just a little instrument that doesn't involve any code and added to your app. I'll go back to the slides to see the photo of this, but the other instrument, so we looked at system logs, looking at the messages in Xcode or in instruments and filtering them, plotting existing logs in a custom instrument. And where I've used this in the past, in particular, was we have several video players in the app that I work on, and when you use AV Player or the other media frameworks, it will log errors to an error log, which you do get a callback for, but you have to implement it, and you're not required to implement it. So one idea is you could make a custom instrument. Also, I posted these instruments. It's linked in the notes. There's a repo up where I started to collect some of these. So if you want to look at those, they're up on GitHub. And so this is one of them, and it basically just parses through the core media logs that are happening and plots the logs. And it will also plot, it'll plot jumps. So when you seek, essentially, it'll plot that log. So they have all kinds of logs for various things that happen to the player. You can tell if it's buffering and things like that. And this was useful for us because we had HTTP errors coming back while the player was streaming, and we didn't realize that they were failing, and it was kind of hard to see the messages. So this gives you a nice visual way to stick it in instruments and see it being logged. So after a little bit of time, you've been working on a project. Maybe you kind of are starting to look like this guy, and you want to make it easier for other developers on your team, new to your team, who are coming in and make it, an easier process to debug this stuff. And we've looked at a bunch of tools, which you can probably imagine you can customize to make that process easier. So let's take a look at specifics. So I'm going to take a look at Xcode. I'm not going to show this because it's fairly small. There's not too much you can do with Xcode. You can't really change a whole lot. I did want to point out the mini-map, which I'm sure most of you have probably seen. The mini-map shows text. I didn't line that up, but text where the mark comments are, similar to the jump bar, so this isn't really anything new. But I think it gives a really good way of sort of showing the topography, because you can also see how long methods are. And the other tip that I learned is if you hold command while you're hovering over the mini-map, it'll show all the symbols like the jump bar. And then the space in between the symbols is the length of the method. So in this case, this project has a 160 line view controller, and you can, pull this up and kind of see at a glance, what's taking up all the space if you needed to refactor. So that's it on Xcode. So LLDB. So you can set up breakpoints in LLDB. We looked at setting up breakpoints and for things that might be more common, but I think one of the most powerful uses of LLDB is making it specific to your app, right? So if you have things that need to be done or states that you can't get into that are difficult to reproduce, or that you need to call some really long method on, you can add commands for all of that stuff. I have not seen many projects that do this, but I've started kind of trying to do this. We have situations where we have expiring tokens, things like that take 30 minutes to expire. So these are situations that are difficult to reproduce, and you have to sit there or try and figure out some other method to do these things. And so you can set a command and call whatever code you want. So some examples, like I said, clearing, expiring a token, clearing cookies on an HTTP cookie storage object, clearing cache objects so you can see how it reacts when you lose everything in your cache and have to refetch it. And the other piece is retrieving information that you might not show in your UI that you need, right? So in our case, we actually don't show the username in the UI, so that's annoying when I'm working with 20 different accounts and don't know which account I'm logged into. And then other pieces would be tokens, right, that you don't show in the app that you need to verify or pull out and use somewhere. And you can do all this, without hooking up to a proxy or some other thing that complicates things. So scripts can be loaded from LLDB init, like we looked at. They can also be loaded from a breakpoint. And I tend to load them from a breakpoint for this purpose because I haven't figured out yet how to really load it from another folder without loading it on everything. There used to be an option to load LLDB init files from your project directory, but that got taken out for security reasons. And as far as I can tell, LLDB init is loaded before the target loads. So if you try to load Python scripts and stuff, they won't get added to the right target, and I haven't figured out the API to wait for the target to show up. So let's take a look at a couple examples of this. Okay. Actually, go here. So I've just set up some commands, and I set these up in Python. They really don't need to be set up in Python because they're all just running LLDB commands. So they're not really very complicated, and they just call deeply nested, data structures and stuff in the app. So in this case, we go into app delegate in the app controller and that GitHub client that we saw earlier, and then in the user session, there's a username, and we just can print that out, right? And I also set these up in Python because you can do a lot of other stuff with the Python API. It gets a little bit complicated, but running this code is quite slow. So if you have a way to do it by just pulling the values out, which you can retrieve, like when you call these commands, it'll call you and give you some of the state. But if you, this is the much easier way to do it. So, and then we've got, really long strings like this, HTTP cookie storage, which is buried inside of our URL session and stuff, and then just clearing that out. And I also, there's a cache that this app uses, so we clear the cache. And then I also have a method to update the badge. And these are all on the fork if you need to look for it. So let's take a look at this. actually, I should probably set my breakpoint first. So to set this breakpoint, we can just add a symbolic breakpoint for UI application main. And then, yeah, we can just use a debugger command. And you do have to use the fully qualified path, which is the other problem with this stuff. So, kind of a annoyance. I'm going to leave it breaking so that we can make sure that it actually hits. And so you can share these breakpoints. If you've never done that before, you can just share this, and it shares in another file. And I like this approach. I don't know if you've ever looked at the way the breakpoints are stored. They're stored in an XML file, which you can theoretically move around. But I find it much easier to set these all up in these files and then just use those and load them whenever you want. There's no built-in way to, share that stuff or have multiple breakpoint lists loaded at once, which would be nice. So this gives you kind of a similar way to do that. So if we're running our app and it's got all the data, so if we pause, you can type help and you'll get all of your custom commands at the bottom. And I typically prefix the commands because then when you start typing them, you can get auto-completion if you hit escape. So we can just run this and it will go into that object and print out the string. And then we can clear the cache. And so if we start running again, all of the messages are gone because they're in the cache. So that's just kind of an example. There's a couple other examples in there. I won't go through all of them, but you can take a look at those from the notes. So a couple other tips really quickly about using that stuff. So the apropos command is really useful when you're starting to look up this stuff. It searches all of the properties and strings and just everything in the help stuff that LLDB provides. And not all of it's shown in the help menu. So if you're looking for specific properties, that's a good tool. The other thing is if you're logging and typically you see the LLDB logs in the console in Xcode, but you also see all of your application logs, so it's really difficult to parse through. You can log them directly to a file, and you can also specify certain APIs in LLDB if you really need to do that. So that can be useful if you're trying to figure out what's going on when it's not working. The other piece is for the Python API. If you basically receive an object called SBValue, and that object can have a value or an error. And if you need to get the string description of that error, you can call getError and get cstring, and it'll print out the string if you're trying to figure out what's going on. Okay, so now last I want to take a look at custom instruments built for the application, right? So we looked at some for system APIs, but we have a lot more control, obviously, when we're doing the logging and we know exactly what's going on. And again, I think it's a really valuable tool. And it's really valuable in this case because it's really simple and highly customizable, so you can make relatively complex instruments and almost anyone can use them, right? They can drop them in and see errors or whatever's going on, and then they just have to know how to open instruments and drag an instrument over. You can also share the instruments as distribution packages, which we can look at, and then you can share templates to have multiple instruments if you have some, a series of instruments for a particular use case. So again, looking at unified logging, there's OSLog and OSSignpost are the two main APIs. OSLog is kind of an NSLog replacement. Signpost is just like logging but with time tracking, so it's like an interval of time. You start and stop, and it will figure out and record how long it took. And you can also put event data and stuff while it's actually running, so you can stick pieces of information in that you can then use to filter later. And then the other thing to note is a lot of this stuff is relatively recent. I think the signpost stuff, or some of it, was added in iOS 12, so you'll have to do a lot of availability checking if you're not supporting the absolute latest version. And then the other piece we're going to take a look at are the actual instrument's XML format. And so a couple easy pieces, there's a schema definition, which is basically maps to those logging types that we talked about, or the logging methods. They basically get dumped in a certain table, and then you can filter them, and the schema definition tells it where to pull from. So you have OS log and OS signpost. And so an example of that, if you have an OS log, which is just logging into info here, it has a log object which tells it the category and subsystem, so you can filter, and then you just have like a normal format string with some data. So that would just become in the pattern matching, which we'll look at. It would become this string, and they use this question mark variable syntax, which we'll talk a little more about later. And there's no, concatenation stuff. You just put the string in and then your variables. And so you need to be careful about this, obviously. If there's anything slightly different, it won't match. It also won't work if the data types are different. So there's a whole list of data types that, string or bool or whatever you're passing in based on the format string. And then the instrument definition itself is just an XML block instrument, and then it has a couple properties like informational, title, and description. And then you can you describe your UI of the actual instrument, right? So you'll take the table that you define in the schema, and then you'll use that table in the instrument and tell it how to display it. So you can use a graph, you can use a histogram, that's the top part, the track or the lane. And then you can use list, which is just kind of like what we looked at earlier, just a list of values. You can use like stack trace stuff, like the stuff you would see in leaks, or system profiler. So there's a whole range of things that you can use if you really start to get into it. So let's take a look at one of these. Just switch over here. So I've gone ahead and added this in because I'm not going to spend time typing all this stuff out. We just log when this variable changes. So this happens when there's a search view controller when we start typing in the input field, and we just log whether it's loading when it starts to load for the request, and then when it gets results. I also added a point of interest, and this is something I often do for like view controller changes. So when you're showing and hiding a view controller, like if you have an analytics library, you could do this at the same time you're tracking screen views or something if you do that. But it gives you some reference on the timeline as to what's going on, around the rest of the logs that you're getting. So you can figure out, they switched to this screen. Obviously there are a bunch of other things you could use, but this is basically a reserved table where you can, there's no other data basically. So you don't have to fight with Apple APIs and stuff like that. And then I also added some signposts, which is also a pretty typical use for HTTP requests. And so this library has a HTTP network transport class, and when we start it, we just log, and then we include the URL so you know what's being requested. And then when it comes back, we end it and URL, and then also append an error if there was one. So I want to take a look at this without making any custom instruments, because the custom instrument stuff gets complicated and deep pretty fast and doesn't have a whole lot of documentation up until some of it has some. This last year they added a sample project. So we'll just take a look at OS log instrument again. So the same one we pulled in earlier, and OS signpost. And there's a separate points of interest. And so we'll run all three of those so we don't have to write any code, right, to make our instrument. And you can get a surprising amount done out of this. So we don't see any signposts yet because we haven't done anything. So if we go into search and we start searching and making these requests, hopefully, where did it go? Okay, it's not working. This has happened a few times. Sometimes this, I don't know if it's this beta, but it doesn't chart the signposts. So let me quit. I'll restart it. It may or may not work. So these three again, and you can add templates. Like I said, that's what shows when you first pull up the document creation pane for instruments or templates, and you can save those just from the file menu up here. Save as template. And so then you can just save those out. So they don't have to be your own instruments. They can be any set of instruments that you might want to reuse. Let's see if this happens. It looks like it's happening down here. Let's see if it charted it. It's still not charting it. So let me just pull it up. I've got a pre-recorded version. So let's do this. So this is what it should look like. And it usually works. This beta's been particularly bad, but so what I wanted to point out is, so these are the operations that we were logging, and you see the URL, which is always the same because this is the GraphQL API. But there's some overlap here as it moves on to the next request, right? So you type a character, it sends a request, and then you type another character, and that request is still going, and then comes back, and it tosses the result, and it's on this next one, right? So we don't really want that, right? We want it to stop when we don't want the results anymore. So, also just a caveat, this is not a real bug in this application. I just removed this line because it was fairly easy. But we just want to request, we want to cancel this request when we get a new loading state, right? So when it changes from loading to loading again, we just want to cancel the last one and continue on. So these are the templates, the default templates. And when you make your own, they show up in custom, right? So you can set several templates up, and then when you install the instrument, it'll pull from whatever set that you have installed. So, the breakpoint is on. Okay, so we can attach to a running. One other note, it's called free time because they didn't change the project name. So if you're looking at that, that's going on. I'll just look at OS signpost since that's kind of the critical thing here. Oh, I didn't show the points of interest, so let me pull that back in. So if we attach, and if we move around, you'll see that point of interest is showing the bookmark view controller, showing the notifications view controller. So it's just the view controller switches. So let's see if this plotted. It looks like it did. That's the initial, one of the earlier API requests. Let's do some searching. And if it actually recompiled. Oh, I guess it just searched once. Let's try it one more time. Yeah, there it goes. So you can see it's stopping the other request. And if you take a look at that in the logs, we should see, that there's an error there, which is the canceled, request error. And so you can make a custom instrument, and for this, there is one in the fork that makes this look a little bit nicer. But I just kind of want to get the point across. You don't have to make the custom instruments. You can, especially with Xcode 11, which adds these lanes where you can have the hierarchical lanes, so you can just drill down. Before, you only got like signposts, so the timeline would just be everything. You can filter the list, but you can't filter the timeline. But now you can drill down to what you want, and you can pin it at the bottom, so you can just always see what's there. The pins, I don't believe, save with a template though, or I think the trace, so you have to re-add them every time. Okay, so that is a quick example of the custom instruments stuff. A couple pointers on that. Again, make sure the formatting's correct, obviously. And then let me actually show this. We have maybe a little extra time, which is getting help on instruments. I didn't know this link existed. I don't think it's in documentation. Maybe it is now. But if you go up to help, there's a new instruments developer help. And there's a whole set of documentation there that describes the package definition stuff. So all the elements that you need, and then a huge list of engineering types. The list is super, super long for like everything. And the power of this stuff, right, is that you can pass something in, like say the size of a file or the size of an object or whatever, and it understands the units and things like that. So when you can then go and take it and use it for statistical analysis, like you can tell the average of something. So that can be useful in certain situations, like network requests, where you want to tell the how big the network request is and stuff like that. Also use the schema. There's an instruments inspector which lets you see the modelers and recorders and stuff that you add with a custom instrument. The WWDC talks go into this in a little more detail, so I'm not going to cover it again. Another thing that I found when I was looking at some of this stuff is I wanted to read these trace documents. It's a closed source format, right? Like Apple doesn't document it, but there is an open source project that pulls in the private frameworks that Instruments uses to read the trace files and then dumps them as text. And it still works. It's been around for several years. You could theoretically use it for CI or something if you wanted to. I've thought about doing that. I'm not sure it's a good idea because you're obviously relying on that stuff never changing. It's in Objective-C, and you have to do a whole lot of obviously dynamic dispatch kind of stuff because it doesn't have all those symbols. But you can take a look at that. So I want to talk about clips really quickly. So Instruments uses clips to create these modelers and recorders, and clips was developed by NASA in 1985. It's an expert systems language. It's a Lisp variant. So there is some documentation on it, but it's all pretty academic because it's used in that situation. And so you can find some manuals. I've included a link in the notes that I posted. And Apple doesn't have any real documentation of this. And up until last year, there was no sample code. But there is now a really huge advanced modelers sample project, which has pretty advanced stuff. So it has like 4 or 5 files that are 200 lines apiece covering this stuff. And of course, the biggest problem with clips is if you didn't like brackets in Objective-C, it's Lisp, so you get all your parentheses instead. But I'm not going to go through this because again it gets pretty complicated, but I want to point out one thing that I didn't realize until I was starting to look into this stuff more deeply. You don't have to write a full modeler or recorder to use clips in an instrument. So you can still use the XML file and then use parts of clips to just inline in the XML file. So an example of that, when you create a schema, you set an expression which matches the variable, like I was showing the question mark variables from the pattern, and you can add like a full clips expression in there so that it maybe like translates the value of that, which is particularly useful for Apple's APIs because they don't always use the engineering types. I guess they have legacy logging or something, so they'll log like strings for all kinds of different things. So here's a quick example of how to match like an optional. So if you just have an error that's an optional, and it'll print a string that's nil, right? And there's a string compare function, and then you just check that it's 0 because it'll give you a greater than or less than value, when it compares the string. And then you can return just a success or error string, and there's a type that takes that and will turn it into a color for the markers on the timeline. So yeah, it'll turn into green or red, depending on what you want to do. Again, that stuff is in the instruments documentation, like the engineering types, but this stuff is very difficult to find. And so the good thing is that they have pretty decent errors, so when you compile the XML, if you get something wrong, it'll show an error, and they have like regex examples, the regex they're using, right, to match these. Similar example, we're just matching yes for a Boolean, and turning it into an integer, which is what clips uses or instruments uses for the Boolean integer type. So just returns 1 or 0. Okay, so we took a look at Xcode and some different ways to navigate, and hopefully you can take some of those and make it easier to navigate through the next big project that you take on. We looked at LLDB and using named breakpoints to enable and disable multiple breakpoints if you want to, or categories of breakpoints. And then we took a look at instruments, and we used system logs to make our own instruments for those, and then also did some of our own logging and took a look at that. So that's it. You can follow me on Twitter or other social networks at BJ Titus. I work for a company called Mercury that has done iPhone development for 10 years or so. And then all this stuff is at titus.io/360. I posted that in the slides. I'll post the slides. I haven't put them anywhere, but I can upload this. So, any questions?